At 9:17 in the morning. The world changes forever. Scientists have spent months trying to stop it. They failed. A massive asteroid is now entering Earth's atmosphere. There is nothing left to launch. No second spacecraft. No second attempt. No way to move Earth. And then it hits. The question is no longer, can we stop it? The question is, what happens next? From space, the asteroid looks almost peaceful. A dark object crossing a blue planet. But as it enters the atmosphere, everything changes. The air in front of it compresses violently. Temperatures rise to thousands of degrees. The asteroid begins to glow. Behind it, a trail of superheated gas and debris stretches across the sky. For a few seconds, millions of people may look upward without understanding what they're seeing. Then the atmosphere becomes the first thing to react. The asteroid reaches the surface. And in less than a second, an enormous amount of kinetic energy is released. The ground doesn't simply crack. It is violently displaced. Rock and soil are thrown upward. A crater begins forming almost instantly. The surrounding landscape is transformed. And the atmosphere receives a shockwave moving outward from the impact site. But the most important thing to understand is this. The destruction would not remain where the asteroid landed. The planet itself becomes part of the event. The first minute would be dominated by physics. A powerful shockwave races outward. Buildings near the impact zone are overwhelmed. Windows can shatter far beyond the immediate impact area. The ground shakes. Air pressure changes. And enormous quantities of dust and debris begin moving through the atmosphere. For anyone close enough to see the impact, there may be almost no time to react. For everyone farther away, the first warning could arrive as something much more ordinary. A flash. A distant sound. Or a sudden earthquake-like vibration. The atmosphere carries energy remarkably well. A massive impact can generate pressure waves that travel enormous distances. The farther the wave moves, the weaker it becomes. But if the asteroid is large enough, the affected area could still be enormous. Cities could lose power. Communications could fail. Transportation networks could be disrupted. And millions of people could suddenly realize that this isn't a natural disaster happening somewhere else. It is happening. Everywhere. But what if the asteroid strikes the ocean? This is where Hollywood often gets it wrong. A giant impact into water would not automatically create a single perfect wall of water covering the entire planet. Reality would be more complicated. The impact would generate enormous waves and disturb the ocean around the impact region. The exact consequences would depend on the asteroid's size, speed, angle, and location. Coastal regions could face devastating flooding. But the ocean would not behave like a bathtub. Its geography matters. Continents matter. Depth matters. Distance matters. And so does the size of the asteroid. Then comes something that could affect the entire planet. Dust, rock vapor, and other material can be thrown high into the atmosphere. Some of it eventually falls back. Some can remain suspended. And depending on the size of the impact, the atmosphere could become part of the catastrophe. Sunlight can be reduced. Temperatures can change. Weather patterns can be disrupted. And ecosystems far from the impact site can begin experiencing consequences. The asteroid may have struck one location. But Earth doesn't have isolated systems. Everything is connected. By the time the first night arrives, the world may look strangely familiar. The same planet. The same moon. the same stars. But millions of people could be without electricity. Communications may be unreliable. Air travel could be disrupted. Supply chains could begin failing. Hospitals could be overwhelmed. And governments would face a problem unlike any ordinary disaster. They wouldn't simply be responding to an event. They would be responding to a planet-wide chain reaction. 12 hours after the impact, the immediate destruction would no longer be the only concern. People would need information. Where is it safe? Which roads are open? Where is food? Where is clean water? Which communications systems still work? And perhaps the most important question: what happens next? Because humans are remarkably dependent on systems we rarely think about. Electricity, satellites, fuel, transportation, internet infrastructure, food distribution. Remove enough of those systems, and modern civilization becomes surprisingly fragile. 24 hours after impact, Earth would still be here. That distinction matters. A civilization-changing asteroid does not necessarily mean the planet explodes. Earth is extraordinarily difficult to destroy. The real question is what happens to the civilization living on it. Depending on the asteroid's size and impact location, the consequences could range from severe regional destruction to a global environmental catastrophe. The dinosaurs faced an asteroid impact roughly 66 million years ago. They had no warning system, no spacecraft, no planetary defense agency, no second chance. We have something they didn't: knowledge. So could humanity survive a massive asteroid impact? Possibly. Humans are adaptable. We live in deserts, at high altitudes, in polar regions, underground, and across 6 continents. A catastrophic impact would not affect every location equally. Some regions could remain habitable. Some infrastructure could survive. And humanity's ability to communicate, organize, and cooperate could become more important than technology itself. But survival would not mean returning to normal. It would mean rebuilding. And this brings us back to the most important lesson. The best time to deal with an asteroid is not after it hits. It is before. Every telescope searching the sky, every orbital calculation, every planetary defense mission is part of the same equation. Find it, track it, understand it, and if necessary, move it. Because once the asteroid reaches the atmosphere, our options become dramatically smaller. There is something strangely comforting about the idea of an asteroid impact, because it feels like an unavoidable disaster, a cosmic event, something completely beyond human control. But that isn't entirely true. The impact itself may be beyond our control. If we discover the asteroid too late. But discovering it early changes everything. Years can become decades. A tiny deflection can become a safe passage. And a spacecraft can become the difference between an impact and a close encounter. The first 24 hours after an asteroid impact would be terrifying. But perhaps the most important 24 hours are the ones long before it arrives. Because somewhere in the darkness of space, the next asteroid is already moving. We just have to find it before it finds us.